Finally, we have D, the dependency inversion principle. The dependency inversion principle states that high-level modules should not depend on low-level modules. Both should depend upon abstractions. Secondly, abstractions should not depend upon details. Details should depend upon abstractions. The idea of high-level and low-level modules categorises classes in a hierarchical manner. High-level modules or classes are those that deal with larger sets of functionality. At the highest level, they are the classes that implement business rules within the overall design of the solution. Low-level modules deal with more detailed operations. At the lowest level, they may deal with writing information to databases or passing messages to the operating system. Of course, there are many levels between the highest and the lowest, and the DIP applies to any area where dependencies exist between classes. The easiest way to describe the DIP is with an example. Consider we have a banking solution. As part of the software, it is necessary to transfer money between accounts. This may involve a class for a bank account and an account number and a balance value. It may include methods that add or remove funds from the account. To control transfers between accounts, you may create a high-level transfer manager class. This may have properties for the two accounts involved in the transaction and for the value of the transfer. For example, as you can see, we have the individual classes for the bank account here, and the transfer manager takes a bank account source, a bank account destination, and implements the transfer. But as you can see, the transfer manager is directly implementing the bank account class. Should we need to make any change to the lower level bank account class, this could have a direct impact on the transfer manager or any other class that implements one of the bank account classes. Using the dependency inversion principle, what we need to do is create two separate interfaces, a transfer source and a transfer destination. Each one is responsible for the method we want to implement. When we then create our bank account, we implement both these services. Therefore, when we come to creating the transfer manager, instead of referencing the concrete implementation of bank account, we just reference the interfaces that we are bothered with, depending on whether it is the source or the destination. That way we can substitute different classes provided they still implement those interfaces, and it makes our application more loosely coupled.